Hi everyone, this is Mrs. Bustamante. This is a continuation of 7.1 Introduction into Natural Selection. So I just want to kind of wrap it up here. Where did we leave off? We kind of left off with Darwin, right? And his theory of natural selection that we used to explain evolution that we still currently use today, right? What are some things that he said? In his theory, you had to have variation in a population, right? But there's another part to this. The variation in a population must be hereditable. What does that mean? It means that that variation that you have has to be passed down from one generation to the next. And that variation actually could either be helpful or harmful, which will explain some results later on. So what do I mean by hereditable information? Well, I actually have my ears pierced, right? So it's something that I have changed about myself, I guess you could say, in my life. But that's not a hereditable trait, right? My children, when they were born, did not also have pierced ears, right? They could have the shape of my ear, they could have the shape of my chin, maybe some other genes, but this is not a hereditable trait that would get passed on. So it has to be something that you can pass on to the next generation when we're looking at this variation, right? We also have to have competition. You have more offspring than can survive, right, which creates competition, which allows for the selection of adaptations that are more beneficial in a given environment, meaning certain organisms survive that have these adaptations that are helpful, and they get passed on to future generations. What does that mean? Well, then we have selection, right? Over many generations. We're talking like thousands, if not millions of years, right? Certain traits get selected for and become more prominent over time. Now, something to note, right, is that Darwin actually couldn't explain the cause of the variation that he was seeing. He didn't know about genes and how they passed on. He and Mendel were in communication, I guess you could say, with each other, right? So he didn't know what was causing this variation. He just knew it was there. And I just like this picture of beetles, right, to show us when we talk about helpful or harmful, there are probably billions of different, I don't know, millions beetles around, and they don't all look the same, right? But they have some sort of adaptation that is helpful in the environment that they live in that might actually be harmful to them in some other place, right? Maybe in their environment it provides some sort of camouflage, but if they were somewhere else, it would provide that camouflage. It would probably be harmful to them. So that leads us to the idea of fitness, okay? And we're not talking about like a workout at the gym, right? But a fitness of an organism, right? Or really maybe even a population is a measure of an organism's reproductive success. That means, can they survive? And then can they produce fertile offspring? Fertile offspring is important because can their offspring go and produce more offspring later on is what it's measured. It's often measured by the number of young contributed to the next generation. And remember, it has to be hereditable, right? We have to have traits or adaptations that we're able to pass on from one generation to the next. So what do we mean by that? Let's say we have some starting population of snails here. Look at the lots of different colors. And there's an overproduction of those snails, okay, which creates some competition, right? And these eagles or birds, whatever they might be, come in and eat them, right? So there's variation and competition in them. But some of these snails, it turns out, like, are easier for the birds to see. Looks like the red ones and the purple ones and the green ones versus the brown ones. So over time, right, those are the ones that get eaten more likely. And so we see over time that that population has trended more towards the, looks like light brown snails because they were more likely to survive. So what's an adaptation? An adaptation is just a trait that helps an organism be more suited for its environment. It's shaped by natural selection, typically doesn't just change for no reason. In a population, remember population, not an individual. And selection is based on biotic and abiotic factors in which the phenotype is more or less beneficial, right? So it can change based on the environment, right? The environment can affect the rate and the direction of evolution, or if change happens at all. So you can see, right, against this dark brown mud, for example, the light mice stand up more. They're more likely to get eaten. But in a different environment, say where it's really dusty, the dark mice would stand out more likely to get eaten, less likely to reproduce. And finally, I want to talk about stability, okay? So things that are stable, we say don't change very much, and things that are unstable are going to have more change. So environments that experience major disruptions can change quickly or slowly over time. And that's going to influence the populations that we see somewhere. So populations are less likely to evolve in environments that remain stable over long periods of time, right? If this is your habitat now, and you'll notice this picture is from AP Classroom, if this is your habitat now, in 20 years it looks pretty the same, and in 60 years also looks the same, you notice that the organisms in it haven't really changed much. But if you have, say, like some sort of volcanic eruption, that's going to change the habitat, the environment pretty quickly, right? And that will cause probably a more prominent change in your population as far as what you see is available. So the more stable unstable the environment, the faster the rate of evolution, or the faster we see a change in that population. I hope this was helpful, and I'll see you soon.